Graphing and modeling sine and cosine. All right, what we're trying to do here is we need to be able to look at sine and cosine functions. Now, the amplitude, period, phase shift, and vertical shift of sinusoidal functions can be determined when the equations are given in the form f at x equals a sine and so on. So we've looked at these types of equations already, and you can actually determine the period, amplitude, period, phase shift, and the vertical shift based on those. Something else you can determine, or you should know, is that the domain of a sinusoidal function is actually any real number. The range of a sinusoidal function actually ranges from the minimum value all the way up to the maximum value. And how to calculate the minimum and maximum is that you take the equation of the axis, you subtract a to find the minimum. Okay, now remember it's the absolute of a. And to find the maximum, you take c plus the absolute of a to get the maximum. So the equation of the axis, the vertical shift, is very important for us because it helps us tell us where the middle is, and we either add a or subtract a if we're trying the max or the min. Now, the equation of a sinusoidal function can be determined given its properties or graph. So that's going to be kind of neat. We can actually work backwards and be able to figure out the equation. So here's one. Here's an example. Looking at this, we have to be able to trace either a sine or a cosine function. Now if you look up here, it's very hard for us to trace a cosine. Notice here, this does not begin at a nice number. Neither does this maximum. Neither does this maximum, and neither does this. And the same can be said for the minimums. So I recommend that we don't trace a cosine function here because we're unable to determine the equation right now based on what we have. So let's see if we can trace out a sine function. Here is a nice sine function. Do you see that, what I traced out there? Here's another one if I trace it over here. And here's another one if I trace it over here. So the idea is we need to find one sine function, and the ideal sine function is actually closer to the x-axis, the closest to the x-axis as possible. But that's okay, folks. Wherever you draw your sine function, I'll determine your I can figure out what your equation is. And so should you be able to. So we're going to trace a sine, determine the equation, and we're going to trace a sine function. Okay? Now, we want to determine equations two different ways, and I'm going to show you how to get the cosine function, but that's only after we get the sine function. So, we need to trace out a graph. How do we figure out all the other pieces? Well, let's see. We can determine the amplitude, because the amplitude is the max minus the min divided by 2. We know the max is 5, we know the min is 1, 5 minus 1 is 4, divided by 2 gives you 2. So the amplitude is 2. We have our A value. We can also get our C value. Our C value is the max plus the min divided by 2, and that's going to be 3. Now the K value. What do we know what the K value is? Well, we have to trace one cycle, just like we did here, determine the length of that period. How long is the period? So it goes from 30 degrees to 120, which turns out to be 90 degrees. And then from that, we're able to figure out the period. But before we could do that, we could actually, based on this tracing, figure out where the middle is. Because remember, the middle, okay, so we have our middle is 3. We have our max minus the min, which is the amplitude. The amplitude is from the middle up and the middle down. So the distance between the middle to the top and the distance from the middle to the bottom. And finally, we need to know our D value. So our D value is where we start our cycle. Wherever we start our trace, that is going to be your D value. So our D value is right 30 degrees because it starts 30 degrees from the y-axis. Because remember, a basic sine function actually begins on the y-axis. just like such. Remember, a basic sine looks like this, and a basic cosine looks like this, and they both begin on the y-axis. Because our trace moved 30 degrees to the right, we write right 30. Now, going back to the period we figure is 90 degrees. 90 degrees is equal to 360 over k, or 1 over k times 360. That's 90 degrees, folks. 1 over k times 360. Our cycle is the regular cycle, like this. It is not the upside down version of this. So 1 over k times 360 is equal to 90. K is equal to 360 over 90, which is 4. Now, does that make sense? I want you to understand why. Remember that the cycle is 90 degrees. It normally is 360 degrees, which means we've actually shrunk this by a quarter. A quarter of 360 is actually 90 degrees. So this makes sense why it's 4. Remember that when we talk about a stretcher compressed horizontally, it's always 1 over k. So our equation is going to be y equals 2 sine 4 times x minus 30 degrees plus 3. Now, how do we convert this to a cosine graph? Well, a cosine graph is a little bit unique. What makes it unique from a sine is that a sine and a cosine is only a shift from each other. To make a sine become a cosine, as you can see sketched here, means that this sine graph has to move this way to become a cosine. How much is that? Well, it is right a certain number of degrees. We're not sure exactly how much just yet, but I'm going to tell you through the use of a basic graph. You guys know for a fact that to go from 0 here to this up here, so to the top, we have to move a total of 90 degrees in a basic sine to go to a cosine graph. We have to move to the right 90 degrees. How much is 90 degrees and why 90 degrees on here, but it definitely won't be 90 degrees on here because the whole cycle is 90 degrees. So that doesn't make any sense. Well, let's think about it. 360 is the whole thing. We want to move just a quarter of it to get to the top. So a quarter of the turn. A quarter of 360 is 90. What is a quarter of 90? Because that's how much we have to move. A quarter of 90 is actually 22.5. So we're going to move our cosine graph. Our cosine sketch is actually going to start 22.5 degrees away from the sine graph. 22.5 degrees to the right of the sine graph. So we have x minus 30 already of the sine graph. We're going to move another right 22.5. Where did I get 22.5? That's a quarter of the distance of the entire cycle, a quarter. Because remember, to move from sine to cosine, you move a quarter turn. So you will have 4x minus 52.5 degrees plus 3. Now I'm going to get you to note something. Remember that moved a quarter turn. So 30 to 52.5 moved, it means it moved 22.5 degrees. If I take 22.5 times 4, that number that we moved, that distance that we moved, times 4, that extra d value that we moved, times the k value will always equal 90 degrees. And that's the neat thing, that this is not what I'm talking about. I'm not talking about this kd. What I'm talking about is how much should we change the k. The change in the k, which was 22.5, times 4 will always equal 90 degrees. It doesn't matter what the k value is and what the d value that we moved. Remember, the d value moved. That will always equal 90. We'll see another example of that in a minute. So really important, folks. We have the sine graph, which we graphed and found the period. The cosine graph shares the same period, same amplitude, same equation of the axis. The only difference is we moved a quarter turn to the right, so a quarter turn, quarter extra to the right to give our cosine graph. All right, let's look at another example. So here's one. A sinusoidal function has an amplitude of 1/2 a unit, a period of 720 degrees, and a maximum at 0, 3.5. 3/2. Part A, represent the function with an equation using a sine function. Part B, represent the function with an equation using a cosine function. So let's start with the first thing. What we should do is sketch out what this is going to look like. This will actually help us get our equation. So we know that it has a maximum value at 0 and 3.5. Excellent for us because that begins right on the y-axis. And that's a maximum, so that means that it must mimic our cosine graph. Now, we also know what the amplitude is. The amplitude is 1/2. That's our A value. We also know that the period is 720. So 720 is the period. We can figure out the K value. 720 is equal to 360 over K. That means we switch the K in the period and we get 3. K is also equal to 1/2. So don't get confused with these 2/2, folks, because they're different. The next thing we need to do is find our C value. Well, we know our maximum's at 3/2, and if I subtract the A value, that will give us our minimum value, okay? So, not our minimum, sorry, our equation of the axis. So we take 3/2 minus 1/2 gives us 2 over 2, which turns out to be our C value. Now, C is equal to 3/2 minus 1/2, because 3/2 is our maximum, minus the A value should give us our C value, which is 1. Our C value is 1. Our A value is 1/2. Our P is equal to K equals 1/2. And for our cosine equation, that's a little too much, folks. Let's just go backwards a bit. We have our cosine, y equals 1/2 cosine 1/2 of x. And why is d equal to 0? Well, if you look here, folks, our cosine graph right here, our cosine starts over here and it goes to here, starts at the y-axis. And our basic cosine actually begins on the y-axis, so we had no phase shift, so this should not be indicating a phase shift, and that's our equation of the cosines. We actually did B first because it makes sense to do B. Now we want to do A. So we trace a cycle, and this time I'm tracing an upside down sign. You do not have to trace a right side up sign. It could be an upside down sign. To trace the upside down sign, that's what I did right here. I traced it here. So now I know that my A value is going to be negative. So negative 1/2 sine, okay? Because remember, a sine function looks like this. We trace an upside down sign, looks like that. And how much did we move to the right? So from the black to the green, it moves to the right. How much did we move? We moved a quarter turn. A quarter of the period. The period's 720. How much is a quarter of it? Well, hopefully you're remembering that 720 divided by 4 is going to be, let's see, what value? That's right, to the right, 180 degrees. Now, keep in mind, remember that it was nothing first, and then we moved to the right, 180. But how much the change is, we multiply by the K value, and that should equal 90 at all times. Notice that the A value stays the same. The only difference is it's negative because we traced a negative sign. Cosine and sine change, obviously. The K value stays the same. The C value stays the same. What will change is obviously your D value, folks, because again, it's a different phase shift. All right. Well, that's the end of the video, folks. Have a numerical day. Take care.